6 times the diameter of Earth. Let that land for a second. Not 6 times wider than a hurricane. Not 6 times bigger than a continent. 6 times the diameter of an entire planet, sitting, spinning, locked in place at Saturn's North Pole. A geometric storm so perfectly hexagonal that when scientists first saw it in Voyager data back in 1980, they genuinely thought the camera was broken. Because storms don't do this. Nature doesn't draw straight lines. Nature doesn't make hexagons the size of worlds and then just hold them there for decades. And yet, there it is. This is the Great Hexagonal Storm of Saturn. And the deeper we dig into it, the more terrifying it becomes. Not because of what it destroys, but because of what it reveals about the universe we think we understand. Let's orient ourselves first, because the scale here needs to be felt, not just read. Saturn is roughly 9 times the width of Earth. If the Sun were a basketball, Earth would be a grain of sand. Saturn would be a marble. And the storm sitting on its North Pole? That hexagon alone would swallow 4 Earths whole. Each side of the hexagon stretches approximately 14,500 kilometers. The whole structure rotates, cleanly, precisely, once every 10 hours and 39 minutes. Which, by the way, is almost exactly synchronized with Saturn's deep interior rotation. Not approximately, not roughly, precisely. That's our first red flag. The winds inside this storm scream at 320 kilometers per hour. That's nearly the cruising speed of a commercial jet. But here's what breaks your brain. Those winds are not what's driving the hexagon's shape. Think of it this way. Imagine blowing a trumpet. The air blasting through the tube is fast, chaotic, violent. But the note you hear, that's a standing wave. A stable, resonant pattern imposed by the geometry of the instrument. The hexagon works the same way. It's not a storm in the way we typically imagine. It's a standing atmospheric wave, a jet stream bent into a persistent geometric shape by fluid dynamics we still don't fully understand. The wind is the breath. The hexagon is the note. And that note has been playing without interruption for at least 40 years. If this is already rewiring how you think about weather and planets, you're going to want to subscribe right now, because we're only getting started. Hit that button. It costs you nothing, and it means the universe gets to keep explaining itself to you. So, scientists got to work. In the 1980s and 1990s, fluid dynamicists started experimenting with rotating tanks of water, basically spinning a cylinder of liquid and watching what happened at different rotation speeds and temperature gradients. And they cracked it. Or so they thought. A team led by researchers at Oxford and later validated by NASA simulations showed that when a jet stream circles a rotating planet at just the right speed, it can buckle into a polygon, a triangle, a square, a pentagon, a hexagon. The number of sides depends on the speed of the jet relative to the planet's rotation rate. The math worked. The simulations matched. The mystery, it seemed, was solved. Crisis averted. That is not what happened. Because when the Cassini spacecraft arrived at Saturn in 2004 and spent 13 years watching the hexagon up close, it revealed something the models couldn't explain. Something that kept changing. Something that shouldn't be possible. The hexagon's color. When Cassini arrived, the hexagon appeared a deep, almost electric blue. The surrounding atmosphere was amber and gold, the familiar pale yellow of Saturn. But the interior of the hexagon was distinctly, unmistakably blue. Scientists assumed it was a lighting effect, a seasonal quirk. Saturn's northern hemisphere had been in winter, cut off from sunlight, for years. The blue, they figured, was simply the absence of the photochemical haze that gives Saturn its golden tones. Reasonable. Elegant even. But then, Saturn's northern hemisphere moved into summer. The sunlight returned, the golden haze bloomed across the rest of the atmosphere, and the hexagon? It turned gold. Slowly, over years, the interior of the storm transformed, tracking the season, responding to the sun, changing chemistry in real time. This told us something staggering. The hexagon isn't just a shape in the wind, it's a boundary, a hard atmospheric wall. a self-contained dome sitting over Saturn's North Pole, so airtight that the air chemistry inside it evolves independently from the air chemistry just a few hundred kilometers outside it. It behaves less like a weather system and more like a biome. Or to use a more unsettling analogy, it behaves like a cage. A cage the size of 4 Earths with 320 kmh walls, from which no gas, no particle, and no chemistry can escape. If that just made you stop and stare at the ceiling for a second, same. Drop a like on this video. It genuinely helps more people fall into these rabbit holes. Now let's go deeper. Here's where it gets even stranger. At the very center of the hexagon, there's an eye, a circular, hurricane-like vortex roughly 2,000 kilometers across, rotating independently inside the hexagonal frame. Like a spinning coin inside a spinning box. The eye wall towers 70 kilometers high. The clouds inside it cascade downward like a slow, eternal waterfall of frozen ammonia and hydrocarbon haze. In 2013, Cassini captured something in those images that stopped planetary scientists cold. Nestled within the eye, smaller vortices, miniature storms, dozens of them, orbiting the central eye like a system of tiny moons. A storm, containing a storm, containing storms. The Russian nesting doll of atmospheric violence. And at the very bottom of those cascading cloud walls, we don't know what's there. Saturn has no solid surface to speak of. The atmosphere simply gets thicker and hotter and denser until pressure alone turns hydrogen gas into liquid metal. The hexagon's roots might extend thousands of kilometers downward, anchored not to any ground, but to Saturn's own quantum metallic core. We have never seen the bottom. We may never see the bottom. Pause here, because I want to ask you something. Why does this matter? Why should a storm on a gas giant 1.2 billion kilometers away mean anything to us, standing on a small warm rock near a medium-sized star? Here's why. The hexagon shouldn't exist. Not according to the models we had. Every time we encountered it, in 1980, in 2004, in 2013, it broke our best understanding and forced us to rebuild. Not because we were wrong about physics, but because physics is richer, stranger, and more generative than any single theory can contain. There's a man worth knowing here. A mathematician and meteorologist named Dave Fultz, who in the 1950s sat in a laboratory at the University of Chicago, spinning dishpans of water on turntables, watching patterns form in the fluid. He wasn't thinking about Saturn. He was thinking about Earth's jet streams. He had no idea he was building the conceptual foundation for understanding a storm that wouldn't be discovered for 30 years on a planet he'd never visit. That's how science actually works. It's not a straight line. It's a web, built by people who were curious about something else, solving problems they didn't know existed yet, for storms no one had seen. And here we are, standing at the edge of what we know, staring at a hexagon the size of 4 planets, watching it breathe with the seasons, watching chemistry evolve inside its walls like something alive, watching nested storms spin inside storms like clockwork. And we still can't fully explain it. That's not a failure. That is the most exciting sentence in science. We still can't fully explain it. Because somewhere, right now, there is a graduate student running a fluid dynamics simulation, or a physicist building a new atmospheric model who is going to crack the next layer of this mystery. And they probably don't know it yet. They might just be curious about something else entirely. The universe doesn't reveal itself all at once. It gives you a hexagon, and it waits. We are living in the golden age of planetary science. Cassini ended its mission in 2017, deliberately plunged into Saturn's atmosphere so it wouldn't contaminate its moons. But the data it sent back is still being analyzed, still surprising us, still rewriting textbooks. The hexagon is still there right now, spinning, breathing, holding its shape against a universe that should, by all rights, have torn it apart by now. If you want to keep falling deeper into questions like these, what else is out there that shouldn't exist, but but does, then subscribe and turn on notifications. Every week we find another thing the universe built without asking our permission. And if this video made you feel something, that specific electric feeling of realizing how strange and enormous everything is, leave a comment below. Tell me, what part broke your brain the hardest? I read every single one. See you in the next one.